could I just say something? Yes, I agree with Simon that the engineers are a very technical community, and therefore they're really quite happy with the sort of more command line type interfaces that you typically get with Linux. But we do see that it's a heterogeneous world, and that you'll have, as Bill Gates demonstrated in his supercomputing lecture last year as SCO5, you know, that you'll do some smaller simulations on a Windows cluster, and then you may download those to a Linux cluster elsewhere. And I think that, you know, for the high end, that's not one of our focuses, and we will see that. But the other thing that touches on what Simon says, I come originally from a particle physics community, which is again a very technical community, and so I'm trying to reach out and find out what we can do for various different parts of the scientific community. And it was a surprise to me that they came to me and said, "Why aren't you talking to us?" Well, that's because I know they're technical and they're quite happy using, you know, the more traditional Linux type tools. But it turned out, just as Simon said, that they wanted to develop their C++ codes using Visual Studio and the debugging tools that we provide. Yes, they went and then ran them on the Linux systems, but it shows that what I think we need to do, and we haven't, you know, we've only begun to address that, can we sort of provide a set of tools that enable you to you know, use your codes on whatever platform you like? Can we raise the bar for making scientific computing easier? And it's going to be a parallel world, as we heard from Earl, and so can we provide tools that are really compelling, that make people easier to do their science or engineering? And I think I agree with the underlying point of the question. I think the jury's out. Can we convince engineers that really you can do serious scientific computing using Windows clusters? I think, you know, we hope so.
Okay.
What I think is reassuring to me in terms of the engineers and the environmental scientists and the people in bio that we work with is, from my perspective, I see Microsoft making quite a long-term and deep investment in this in order to help the community to collaborate and in order to accelerate their ability to get insight into their problems. It really does seem to be a very deep and long-term commitment, and that certainly is also important for me in terms of providing a platform that over the next 10, 20 years will be here to support me and here to enable me to do my science.
We hope so.
All right, well, I still have quite a few really good questions here, so I believe we're going to run just a little bit past our 1 hour window and try to get a few more of them in. The next question asks, what new applications for high-performance computing do you see becoming important in the near future?
These are difficult questions, right? I mean,
want me to start with a couple?
yeah, why don't you do that? Well, I think.
Yeah, what do you think? So I think one area that we see on the horizon very much are all related to homeland security and the security applications, and how do you actually address these problems in a way that doesn't affect the population. In other words, if you could walk into an airport, a train station, a bus station, and monitors do something, you know, invisible to you, and as you walk through, say, 50 feet of a corridor, everything's checked, and they already know who you are, and they've already done all those checks, and it's totally invisible to you. And I think that's the end point that a lot of governments would like to get to, and we're a very long ways away from that. But there's just a whole set of applications there. It requires real-time computing. I think it's so large, the database requirements and data structures, that you're going to have something that looks like both a cluster and a grid and geographically dispersed issues. And I think multi-core technology is something that would very much help that problem.
Yeah, to pick up on what Earl said, I mean, yeah, RFIDs, these tags that give you information, so when you walk into a store, they know all the things you bought and where you bought them from and how much clothes you were wearing, how much it cost, and so then they say, excuse me, Tony, we would like to give you these potential options. That's an extreme thing, and there are privacy issues there, but I think that's one application. Another one that I think is really in the environmental area, where I see there are several things being done. There's an interesting project in the US called the LEAD project, linked in Environment for Atmospheric Discovery, which is looking at adaptive sensors for tornadoes, for example, because if you can reduce the false alarm rate from I think it's 75% now, down to 25%, people will take these seriously, and then you can actually save lives. But it's linking all these, flood warning, where you have, real-time weather data coming in, you have sensor networks measuring the actual flow, you have groundwater modeling, and then you have linked to the emergency services. That's flood water, but there's tsunamis, there's all sorts of things. So those environmental ones, I think, are going to be increasingly important, as is hydrology, because, the water tables are falling in many places because we're taking too much water out. There's all these pollutants coming in from farming. What are we doing to the water? Is it long-term sustainable? I think these are going to be important issues. They involve distributed data, lots of processing, lots of data mining. These are, to me, very exciting new applications. And I'm sure Simon has lots of others.
I think those really exemplify the exciting ones. Those are very industrially focused, but again, in terms of, I noticed that a few people on the chat have said that they're kind of in academic research, and what I see in academic research is users in areas of arts, humanities, archaeology, beginning to pick up and understand that the ability to log and record what they've been observing out in the field, the ability to come back and potentially use simulation in ecology to be able to understand and predict the way in which what they've observed in the field can actually be modeled. There are new areas in academic fields outside engineering and outside biosciences that I see coming up that, again, is quite a step change in the way in which those people have previously done their research.
Okay, I think we have time for one more question, and that is, what is the greatest challenge facing HPC users over the next 3 to 5 years? What is the greatest challenge facing users over the next 3 to 5 years?
Okay, well, Simon, off you go.
Well, as a user, I think the greatest challenge is coupling together all of these pieces of technology. I talked a little bit about that workflow aspect of our work, and the ability to couple together seamlessly and securely and very flexibly large-scale computing, large-scale data resources, and the networks and the collaborative tools we have. For me, having environments in which that can be done and in which that can deliver new scientific insight, that for me is perhaps the greatest challenge and the thing that we're certainly focusing on in our work.
Yeah, I think I agree. In the 3 to 5 year time scale, I think that we need to make it so that the resources are fully virtualized, and that you can actually run your program easily wherever it is. You don't need to preload it and have access authorized on the machine in advance. You can really make it so it's truly able to take advantage of resources everywhere. The security issues, the access control, the authorization issues are important, as are the tools. I think that the tools and the standards can help this industry grow. So I think those are key challenges for the IT industry to give to the users. There are other types of resources. Now we're increasingly seeing software delivered as a service, that you can host things, as we say in Microsoft, in the cloud. So you see services hosting computing cycles in the cloud, data storage in the cloud. How can we make use of all these? And those will be real challenges for the HPC users, how to best make use of all these potential opportunities. Longer term, I think the challenge is can we make it so that we can really de-skill parallel computing, so it actually is easier for the users to put their systems together. And that's why I think Simon's characterization of workflow is, if you like, how you program the grid. Workflow is going to be extremely important. Can we make it easy so that people can just plug and play and actually make their applications, take data from here, data from there, mine over here, computer simulate over there? Can you put all these together? And I think that's the challenge for the user and for the developer community, to come up and work together to make that really a transparent way of doing things.
Yeah, I think this is a fascinating question, because to me the challenge is, and I agree with both of yours, but let me take a system view. The traditional HPC home run system design is give me a faster processor, give me a bigger, larger, faster processor, reduce latency to almost nothing, always get rid of latency, give me the largest bandwidth on earth you can give me, and don't make me have to do too much work with MPI, parallel processing, and that. This has been kind of the holy grail of HPC design for multiple decades. The world we live in right now, every one of those have hit a dead stop. And not only a dead stop, they're going to reverse. Processor speeds are going to stop increasing, or they'll be increasing at a small percentage rate. Latency is going to get worse. I mean, because we're going to larger clusters and design. So just, it's a fact of life. The interesting thing about multi-core technology is the amount of bandwidth going into a socket can only increase by a certain small rate. And it's a much smaller rate than going from dual core to quad to 8 to 100 by 2015. So effectively, we have to assume that bandwidth is going to be decreasing by orders of magnitude per processor. Again, total redesign, revamp of what a HPC system looks like. And then we've already talked about dealing with parallelism and multiple hierarchies. So I think the biggest challenge for HPC users over the next 3 to 5 years is to figure out how to redesign your application, how you're using the machine. And I think there's going to be two paths. One path is, let's run everything on a single processor. Now, for the low end of the market, capacity, word processing, and software issues are very easy there. And there's going to be some good solutions. But the larger HPC or more traditional ones really have to rethink entirely how they're using machines. Once they rethink that, then all at once a grid solution fits extremely well too. Because what I also described besides being a system view is kind of what you get from a grid. And so I think there's some interesting changes that will happen in the marketplace.
But I think the IT industry needs to help users migrate to these things. I agree that these latency challenges to memory and bandwidth are going to be interesting challenges, but if we can, we need to hide those as much as possible from the user, but it's difficult.
Every time a vendor or a manufacturer can hide it from the user, the things we've just talked will be a home run financially for the vendor.
I agree.
Users do not want to have to touch this if they can avoid it.
Indeed.
Absolutely.
Okay. I'd like to thank our panelists, Tony, Earl, and Simon, for their wonderful input. I'd also like to thank you for joining us. And special thanks are in order for Microsoft, who has partnered with us to present this webcast. If your question wasn't answered during our discussion and you would still like to submit one, you can send an email to mainstream@scientificcomputing.com and we will pass it along. Please be sure to indicate the panelist to whom you would like to address your question. If you would like to review this presentation or review a colleague to view the broadcast, be aware that it will be archived for 6 months at the URL displayed on your screen. Thanks again, and have a great day.